Hello all, today I will be covering some semiconductors questions based on the last topic we did. So let's start with it. So in this, first question says the manifestation of band structure in solid is due to Heisenberg's uncertainty principle, Pauli's exclusion principle, Bohr's correspondence principle, Boltzmann law. So it is actually the band structure in solids is due to the Pauli's exclusion principle results, and it confirmed how in solids the energy band gaps are different. So let's start with the second one. For non-conductors the energy gap is the energy gap is very large, that is for insulators it is about 6 electrovolt. The right option is A. Third part, which is the correct relation for forbidden energy gap in conductor, semiconductor and insulator. So as you know that the insulator has the largest forbidden energy gap, then we have semiconductors, then we have conductors. So the largest is for insulator and then semiconductor and then conductor. So the right option is B part. Now the fourth one, the valence band and conduction band of a solid overlap at low temperature. The solid may be a metal, a semiconductor, an insulator and none of these. So only condition is when we have a metal. So when we have a metal, the condition it forms is the valence band is over conduction band. Now the next one, energy band gap is maximum in metals, superconductors, insulators and or semiconductors. So out of these all it is insulator. Maximum energy band gap is of insulators. The band gap in germanium and silicon in electrovolt respectively is. So we need to tell for germanium first, then for silicon. So first is for germanium and then it's for silicon. So the right option for this is 0.7 and 1.1. Germanium is 0.7 and silicon is 1.1 electrovolt. The question says that wire P and Q have the same resistance at ordinary temperature. When heated, resistance of P increases and that of Q decreases. That means the resistance value for P increases and the temperature is increasing. Resistance of Q is decreasing and the temperature is increasing. That means the T condition is of semiconductor, because when resistance is decreasing and temperature is increasing, that means it is a condition of semiconductor. That means Q is a semiconductor. So, and T, as resistance and temperature are increasing, that means it is a conductor. So out of these options, the right option is D part, that is P is conductor and Q is semiconductor. Let's move on to the 8th part. So 8th part says the nature of binding for a crystal. For a crystal with alternate and evenly spaced positive and negative ions is covalent bond, metallic bond, dipolar bond and ionic bond. So the right answer for this is ionic bond, because it has positive and negative ions, that too arranged in an alternate way. Let's move on to the 9th question. So the 9th question says if the distance between the conduction band and valence band is 1 electrovolt, then this combination is either metal or insulator or conductor or semiconductor. The right option for this is semiconductor, because it's about 1.1 electrovolt. For crystal system, A is equal to B is equal to C, alpha is equal to beta is equal to gamma is not equal to 90 degree. The system is tetragonal system, cubic system, orthorhombic system, rhombohedral system. So out of these four, the right option is rhombohedral, because in that A is equal to B is equal to C and alpha is equal to beta is equal to gamma is not equal to 90 degree. So the right option to this is B. Let's move on to 11th question. So it says a single representative unit spread out in whole of the material. Which statement is wrong? a single representative unit spread out in whole of the material in order regular arrays gives a single crystal. A polycrystal is composed of grains in which regular periodicity is broken inside the grains, but regularity is maintained at grain boundaries. See, in an amorphous material, each grain is composed of single representative unit. In liquid crystal, periodicity is maintained in only one or two dimensions. So out of these all, C is right, D is right, A is right, but B is not right, as it says polycrystal is composed of grains in which regular periodicity is broken inside the grains, but regularity is maintained at grain boundaries. So that's wrong, it is not there. Then 12th, biaxial crystal among the following is calcite, quartz, selenite, tourmaline. So out of these, it is tourmaline. Biaxial crystal is tourmaline. The temperature coefficient of resistance of a conductor is, so they want to know for conductor. So conductor is always positive, whereas for semiconductor it is a negative temperature coefficient. So let's move on to the 14th. Potassium has a BCC structure with nearest neighboring distance 4.525 angstrom. Its molecular weight is 39. Its density is mass over volume. So when you calculate this answer, you will get your answer as 908. You can verify your answer. At 0 degree Kelvin, Fermi level for metals is. They are asking for metals. So the answer for this it will be, they are separated. They are empty and filled levels. So the right option is A. 16. Which of the following statement is wrong? Resistance of semiconductor decreases on increasing the temperature. That's right. Displacement of holes is opposite to the displacement of electrons in an electric field. That's right. Resistance of a good conductor decreases on increasing the temperature. That's wrong, because on increasing the temperature, resistance also increases in the case of conductors. So C is the option, that is wrong. 17. The expected energy of the electrons at absolute zero is called Fermi energy, emission energy, work function, potential energy. So that's Fermi energy at 0 Kelvin. The energy band diagrams for 3 semiconductor samples of silicon are as shown. We can then assert that sample X is undoped, while sample Y and Z has been doped with the third group and a fifth group impurity respectively, and sample X is undoped with both samples Y and Z have been doped with fifth group impurity. Actually, let's check what is this. So as the sample X is a horizontal slope line, so in this case this is an undoped, X is an undoped one. And the Y has been doped with the fifth group because the energy level has been shifted to the conduction band. So that's for fifth. And the last one is for third group impurity, because the energy level has been shifted to valence band. So the right option for this in this case is B part. Sample X is undoped, Y is with the fifth group, Z is with the third group impurity. Let's move on to the 19th one. In good conductors of electricity, the type of bonding that exists is ionic, van der Waals, covalent, metallic. So this is metallic. The bonding in a germanium crystal semiconductor is, so it is actually covalent bonding in the germanium crystals or any semiconductors. They form a covalent bond. In a triclinic crystal system, triclinic crystal system is A is not equal to B is not equal to C, actually the condition for triclinic is the first one only, because all the angles are different and the sides are different. Metallic solids are always opaque because solid affects the incident light. Incident light is readily absorbed by the free electron in the metal. Incident light is scattered by solid molecules. Energy band traps the incident light. So the right option is incident light is actually very readily absorbed by the free electron in a metal. So 22 is for B. Forbidden energy gap in a pure conductor is. So for a pure conductor, it's not 6 electrovolt. 1.1 is not there. Pure conductor actually have a 0 electrovolt because the valence band and the conduction band overlaps each other, or they are having a 0 electrovolt. Then moving on to 24, in which of the following ionic bond is present? It is NaCl, Na plus and Cl minus. So that's ionic bonding. Solid CO2 forms ionic bonding, van der Waals bond, chemical bond, covalent bond. So the right option in this case is covalent bonding. Which of the following material is non-crystalline? Copper, sodium chloride, wood and diamond. So is non-crystalline it says. So that means the right option is wood, as copper is a crystalline one, sodium chloride is a crystalline, and diamond is a crystalline. The coordination number of Cu is copper is 1, 6 or 8 or 12. So copper is 12. Which of the following is the weakest kind of bonding in solids? Weakest kind: ionic, metallic, van der Waals, covalent. So the weakest one is van der Waals. In a crystal, the atoms are located at the position of maximum potential energy, minimum potential energy, zero potential energy, infinite potential energy. So in a crystal, the atoms are actually located at the position of minimum potential energy. Crystal structure for NaCl is FCC, BCC, both of the above, none of the above. Crystal structure of NaCl is actually FCC. Semiconductor is formed by coordinate, covalent bonds, electrovalent bonds, metallic bonds. Semiconductor is actually formed by covalent bonding. A hole carries a charge equal to 0, proton, neutron or electron. This is the question where everyone goes wrong. So actually the hole carries a proton. It is equivalent to proton. A piece of copper and another of germanium are cooled from room temperature to 77 K. The resistance of each of them increases. A piece of copper and another of germanium are cooled at room temperature to 77 K. The resistance of them: copper is a metal or a conductor, germanium is actually a semiconductor. So it will be copper decreases because it is a conductor, and germanium increases because it is a semiconductor. Now the next one, when germanium is doped with phosphorus, the doped material has excess positive charge, excess negative charge, more negative current carriers, more positive current carriers. So it actually has more negative current carriers. Partially filled electron between forbidden gap is conductor, insulator, semiconductor, all of the above. So the right option is actually semiconductor. They have partially filled electron between forbidden band gap. The temperature T dependence of resistivity of a semiconductor is represented by. So basically when we increase the temperature, it decreases. So in this case the right option is B part. In extrinsic P and N type semiconductor materials, the ratio of the impurity atoms to the pure semiconductor atoms is about. So it's actually 10 raised to power minus 7 impurity atoms to the pure semiconductor atoms. Now look at the energy band gaps. Energy shown in the figure corresponds to that of a semiconductor. So the first one is not right, second one is not right because it represents for metal, and C part is not right as well because Eg in this case is greater than Kt. The right option to this is Eg equal to Kt. So that's right, B part. In a p-type semiconductor, 39, in a p-type semiconductor, current is mainly carried out by holes. The material is always positively charged. Current is mainly carried by electrons. Doping is done by pentavalent material. So it is mainly due to current is mainly carried out by holes in the case of p-type semiconductor. Let's move on to the 40. At ordinary temperatures, the electrical conductivity of semiconductors in MHO over meter is in the range. So electrical conductivity of semiconductors lies between insulators and metals. So it will be 10 raised to power 6 to 10 raised to power 9. When phosphorus and antimony are mixed in germanium, then p-type semiconductor is formed. N-type semiconductor is formed. Yeah, that's right. It is N-type semiconductor is formed because it has pentavalent impurity. Has 5 valence electrons with antimony. 42. To a germanium sample, traces of gallium are added as an impurity. The resultant sample would behave like a conductor, a p-type semiconductor, because gallium is actually a trivalent impurity. That means three extra electrons are provided to germanium. Donor-type impurity is found in trivalent elements, pentavalent elements. In both the above, none of these. So the right option for this is pentavalent elements. Donor impurity means pentavalent. Acceptor impurity means trivalent. The 44th. The difference in the variation of resistance with temperature in a metal and semiconductor arises essentially due to the difference in the variation of scattering mechanism with temperature, crystal structure, variation of the number of charge carriers with temperature. Yeah, that's right. So the difference arises due to the variation of number of charge carriers with temperature. Now moving on to the next. A piece of semiconductor is connected in series in an electrical circuit. On increasing the temperature, the current in the circuit will decrease, remain unchanged, increase, stop flowing. So the right option for this is will increase. Because the resistance decreases, current increases. When a semiconductor is heated, its resistance decreases, increases, remains unchanged, nothing is defined. So the right option for this is decreases. In a semiconductor, the concentration of electrons is this and that of holes is this. That means electrons are more because it says 10 raised to power 14. In this case it says 10 raised to power 12. That means N is greater than NH. This is the condition for N-type. Now moving on to the next. In intrinsic semiconductor at room temperature, number of electrons and holes are equal, 0, unequal, infinite. In intrinsic semiconductor, this is a pure type of semiconductor. So that's why the number of electrons and number of holes are equal. Ne is equal to NH. The next one, to obtain p-type silicon semiconductor, we need to dope pure silicon with aluminium, phosphorus, oxygen, germanium. So the right option in this case is aluminium. We need to dope pure silicon with aluminium to obtain p-type semiconductor. When the electrical conductivity of a semiconductor is due to the breaking of a covalent bonds, then the semiconductor is said to be donor, acceptor, intrinsic or extrinsic. So in this case, the electrical conductivity is due to the breaking of covalent bonds. So this happens when we have an intrinsic semiconductor. The semiconductor will be an intrinsic semiconductor. So that's all about, in this we covered 50 questions of semiconductor. I will be covering more in the next video. So keep